CSRF is such a sneaky little thing. The attacker never needs to read the response, just abuses the fact that the browser politely carries your cookies everywhere, like an overenthusiastic valet.
Right. So the threat model is basically, user is already authenticated, visits a malicious site, and that site makes the browser send a state-changing request to the target app.
Exactly. If the app trusts cookies alone, the browser becomes the accomplice. Change email, transfer money, delete account, whatever the endpoint will accept.
And it's worst when the request looks normal, like a form post. The server sees valid session cookies and shrugs.
Which is why people who say, it's just a post, make me tired. Post is not magic. I've seen teams treat it like a velvet rope at a club.
The attacker's site can't usually read the response because of same origin policy, but it doesn't need to. It only cares that the side effect happens.
Right? So the core question is not, can they steal data? But, can they trigger actions on behalf of the victim?
That's the part that gets missed. The browser is honest, maybe too honest.
Which is why the synchronizer token pattern works so well in practice. The server issues a unique token tied to the user session, and the client has to send it back on any state-changing request.
So the token has to be unpredictable, and stored server-side, or at least derivable from the session, right?
Yes, usually in the session. Then render it into the form, or expose it through a page-level variable for the front end to include in headers. The important part is that an attacker's site can't read it.
Because of same origin restrictions. If they can't see the token, they can't mirror it in the forged request.
Exactly. No token, no trust. And the token should be checked on every unsafe action, not just the important ones people think of at design time.
That's where teams get lazy. They wire it into one form, and forget the API route everyone actually uses.
Or they rotate sessions and accidentally orphan the token logic. Delightful little bug farm.
I've seen that happen. Someone said, "It's fine, the middleware handles it," and the middleware was handling almost nothing.
Middleware is only heroic in slide decks. In real life, it needs to be wired everywhere, or it's just expensive decoration.
Some teams prefer the double submit cookie pattern instead, mostly because it avoids server-side token storage.
Right. The server sets a CSRF cookie, and the client sends the same value back in a header or form field. If they match, the request is probably legitimate.
Probably is doing a lot of work there, but yes. It's simpler for stateless apps.
Simpler, but only if you do it carefully. The cookie has to be readable by the front end, so you can't slap HTTP on it and call it a day.
And you still need the cookie to be protected with same side where possible, otherwise you're leaving the front door open and admiring the doormat.
I like the pattern, but people confuse it with a free pass. If an attacker can set or predict the cookie, the whole thing collapses.
So the cookie value should be random and unguessable, and ideally the app should verify the header or body value matches exactly.
Exactly. No matching token, no state change. It's elegant when the browser and app are both behaving.
Which is a very polite way of saying, until someone misconfigures cores and ruins my afternoon.
Same site helped a lot, honestly. It's not a full CSRF defense, but it cuts off a big chunk of cross-site cookie sending by default if you configure it right.
Lax is the usual starting point, right? It lets cookies ride on top-level navigations, but not on most cross-site sub-requests.
Exactly. None. Silly cell. Now wall. Good baseline for session cookies. Strict is tighter, but it can break flows that rely on cross-site redirects or external links.
And none means you're explicitly opting back into cross-site behavior, which also means secure has to be there.
Yes. If you're going to say, send my cookie everywhere, you at least need to whisper, over HTTPs while doing it.
The tricky part is compatibility. Some older browsers or embedded clients don't behave consistently, so teams end up with strange fallback logic.
That's where people get overconfident. SemSite is a seat belt, not a force field. It reduces exposure, but you still want token validation for unsafe requests.
Because if someone finds a path around it, you're not starting from zero.
Exactly. D. Thin's in depth. Or, as my old lead said, never trust one clever header to save your weekend.
REST APIs make people complacent. They hear stateless and assume CSRF just disappears.
Which is adorable, because browsers still attach credentials if you let them. If your API uses cookies for auth, it can still be vulnerable.
So the key question is whether the API is consumed by browsers with ambient cookies, not whether it uses JSON.
Right. Me. If it's cookie authenticated, you still need CIF defenses on unsafe methods. Tokens in headers work well because cross-site forms can't set arbitrary headers.
And if you're using bearer tokens in an authorization header from JavaScript, the risk profile changes a bit. The browser won't add that header automatically.
True, but then you've shifted the problem to token storage and XSS risk. There's always a trade.
Of course there is. If the API is truly not browser-facing, CAF is less relevant.
Less relevant, not impossible. Sale. People love saying internal only, right before a browser-enabled dashboard appears 6 months later.
That happens more than I'd like. Someone builds a neat spa on top, and suddenly the API has to care about the browser's habits.
Exactly. The browser is the whole reason CSIF exists. Strip that away, and the threat model changes.